in today's lecture, we will look at one of the exercises given as a programming assignment in the Programming Data Structures and Algorithms course in the week numbered 4. So, this is the most challenging programming exercise among the given ones, and this exercise involves writing a program to sort a given set of words. And this is a discussion about this programming exercise and what kind of programs one can write and the arguments of correctness. So, the exercise involves a collection of words as given as input. The first step that we will perform is that we will read the words and store them in an appropriate data structure. In our case, it will be that the data structure will be an appropriate array. Then we will choose a sorting algorithm to sort these words, and we will indeed use a comparison based sorting algorithm today. And it is important that if we use a comparison based sorting algorithm, then we should have the ability to compare two given words. Let us, for example, choose the insertion sort, and we all know the pseudo code to sort an array which has integers. Here what we do is we look at the array from the first element to the last element, and in the second while loop we sort the first I elements. Recall this, we have already studied this during the insertion sort lectures. The main invariant of insertion sort is that if you look at the iteration numbered I, then the first I elements of the array will be sorted at the end of iteration number I, and this is really the pseudocode. The most important thing to notice here is there is a comparison made between the elements of the array A, the j minus 1th indexed element and the jth indexed element, and if we assume that it is an integer A, then conceptually there is a very clear understanding of what is the result of a comparison between two integers. This is highlighted in blue, and if we wanted to use exactly the same insertion sort idea to sort a given list of words, then we must have a clear understanding of how to compare two words and which of given two words are is the larger among the given two words and whether they are equal and so on and so forth. We need to be able to compare two words. In particular, whatever we are going to discuss really does not matter what the elements of the array are, as long as they are of a single type. So, therefore, we imagine a function called compare, and the result of compare will basically tell us which of the two elements is the larger of the two. So, let us assume that the elements are a of j minus 1 and a of j. The result of compare tells us that whether a swap must be performed or not. If the result is more than 0, then definitely a swap must be performed, essentially saying that a of j is smaller than a of j minus 1, saying that the two elements must be exchanged, and if the result is equal to 0, then no swap needs to be effected because a of j minus 1 is smaller than a of j. So, therefore, what we are going to look at is the implementation of a compare function when the elements of the array are words. So, let us now look at this small function which is used to compare two strings. Let us recall that S1 and S2 are pointers to character arrays, and they are terminated with a null symbol each of them, so that the contents of both these arrays are considered to be character strings. The output of this function is a 0 if the strings S1 and S2 are identical. If S1 has a higher dictionary order than S2, in other words, in the lexicographic ordering or in the dictionary ordering, if S1 occurs after S2, then the return value of this function will be a positive value, and if S1 has a lexicographically lower rank than S2, that is S1 occurs, or the string S1 occurs before string S2 in the lexicographic ordering or in the dictionary ordering, then the return value will be negative. Therefore, the way of using this function in our sorting algorithm will be that if S1 is lexicographically later than S2 in the dictionary order, then the return value will be greater than 0 and we will effect a swap. That is how we are proposing to use the compare function in our sorting algorithm. So, let us just go through this function. It is a nice and tricky implementation using pointers and the fact that characters can be compared by performing arithmetic on their corresponding integer values. It is very important to remember that the integer value corresponding to a character is its unique integer code, which is often called the ASCII code if you are programming in the C programming language. So, let us look at the compare function. What it does is that there is a while loop which iterates till S1 reaches the end of string, and the control remains inside the loop as long as the character under process in the string S1 and the character under process in the string S2 are identical. Let us understand this. If the end of string of S1 is reached, or if the character pointed to by S1 and the character pointed to by S2 are different, then control will exit from this loop. As long as these conditions both are satisfied, inside the loop the pointer value is just incremented by 1 unit, in this case by just the address of 1 byte. When control exits from the loop, the check that is performed is to check if what S1 and S2 are pointing to are one and the same, or is one smaller than the other, or is one larger than the other. And the way this is affected is by subtracting the integer values associated with the corresponding characters. Indeed, if they are equal and the control is exited, it means that both the strings have come to their ends, and therefore the strings are indeed equal and the return value would be 0. If the return is because of S1 reaching the end of string and S2 not being the end of string, then it means that all of S1 is contained inside S2, and the value that would be returned is that S1 is smaller than S2 in the lexicographic ordering. And if S1, the value at the location that is pointed to by S1 is smaller than the value at the location pointed to by S2, then this subtraction will return a negative value saying that S1 is smaller than S2. Indeed, if it is going to return a positive value, then it means that the string S1 in the dictionary order occurs after the string S2, and therefore we will use it to exchange, to effect an exchange or effect a swap in our usage. So, first we create an array of words. It is a 2-dimensional array. The number of rows is max words, which is a constant as given in the input, and the length of the word, the length of the longest word is given, and we use one more location, and this is only to ensure that we will store the words as strings. We will use one more letter or one more character position to store a null. So, now we read the number of words that need to be sorted. This is what the first scanf does, and then the for loop here reads the strings one after the other, the words one after the other, and stores it in the array words. It is very important here to note that if the words are of length more than word length, then the behavior of this program is unpredictable. Therefore, it is extremely important to ensure that the words that are given as input are only words of exactly word length. The last letter will be used to store a null. Then we have an initialization step of another array called order, and this is a very crucial array which is what we base our insertion sort algorithm on. Right. So, order is another array. There are as many cells in this array as there are the number of words or the maximum number of words, and all of them are initialized to 0. Then as we read the input words, the order of the ith word is initialized to I. This is just an initialization step, and most importantly observe what we are doing. We are reading the input words from the input and storing it into the array words, and we are giving an initial ranking which could be wrong, which will be wrong on most inputs unless the words are all already sorted, and the ith word is given the order I, and it is this order that will be changed when we perform an insertion sort. So, now we go to the sorting algorithm itself. For the usage of space appropriately, with the aim to use the space appropriately, we have taken a bit of shortcut. Comp stands for the compare function which we talked about earlier. W letter is a shortcut for the words array, and O letter is a shortcut for the order array that we have defined earlier. So, now what we do, again like in insertion sort, there are two loops. The outer loop runs over the indices 1 to n, and what we do is we compare the first, at the end of this while loop we will guarantee that the prefix of the elements, that is, if you look at the ith iteration of the for loop, at the end of this while loop, the first I elements will definitely have the order values in ascending order. So, let us look at this comparison. In the ith iteration, j is set to I, then while j is more than 0, and here j is decremented and at the end of this, we compare the word whose order is j minus 1 and the word whose order is j, and if the comparison gives you a value more than 0, which means they must be exchanged, then we swap the words order of j and order of j minus 1. We swap the values of order of j and order of j minus 1, then we decrement j minus 1. So, let us understand this algorithm. Initially, we have a current ranking of the n words. At the end of the first iteration, the invariant, as we know, is that the word with order value 1 is sorted. That is, in this case, the first word is sorted. Indeed, every single word is sorted. After the second iteration, the order values or the first two elements are in increasing order, and after the ith iteration, the order values of the first I elements are in increasing order. Consequently, after the nth iteration, all the elements are sorted. Therefore, this is an algorithm to sort a given list of words. Observe that we have used insertion sort in a very clever way, using this order data structure or the order array whose values are changed, and using the comparison function of two words. Thank you.